So in our last lesson, you learned the rules for figuring out how many significant figures there are in a number. Today we're going to add on to that a little bit, and we're going to figure out how do we use significant figures when determining how to round our answers after solving a math problem. So first we're going to look at addition and subtraction. The rule that we're going to follow is that whenever we are adding or subtracting numbers, we are going to round our final answer according to the decimal place of the number with the least amount of digits after the decimal point. So what does that look like? Well, first of all, we need to look at all the numbers that we're working with, and we need to count how many places after the decimal point each number has. We're going to focus on the number that has the fewest digits after the decimal point. We're going to add or subtract our numbers, so we're just completing the problem according to the math operations. And then we will round the final answer according to the decimal place of the number with the fewest digits after the decimal. So I know the steps probably sound a little more confusing than they actually are, so we're going to do a few examples so that you can see what it looks like. If we have 1.20 centimeters plus 0.7 centimeters, 1.20 has two numbers after the decimal, 2 and 0, and 0.07 has one number after the decimal point. That means that we are going to carry out our operation 1.20 plus 0.7. That will give us 1.90 centimeters. But if we think back to our rules, it says we have to round our final answer according to the number that has the fewest digits after the decimal point, and that will be 0.7 that has 1. So we need to round our answer to 1.9 centimeters so that we only have one number after the decimal. So again, we figure out how many digits are after the decimal in each of the numbers that we're working with. We're going to focus on whichever number has the fewest digits. Sorry, I know it gets confusing saying number a lot, the number of numbers after the decimal, so I'm going to try to use the term digits. We carry out our operation, and then we round according to the number with the fewest digits after the decimal. Let's look at another example. 2.0 minus 0.01. Our first number has one digit after the decimal, and our second one has two digits after the decimal. That means we're going to carry out our operation 2.0 minus 0.01, which will give us 1.99. But 2.0 only has one number after the decimal, so we need to round this to have one number after the decimal as well. So we need to round this 9. Since it is a 9 after it, we have to round up to 2.0. Sorry for that line. That is 2.0. And again, you might be like, hey, we did a math operation and we subtracted from 2.0. How can we have that with our final answer? But again, that's why significant figures are so important and understanding the rules for rounding. Do one more example, 3.5 milliliters plus 1.209 milliliters. We count the numbers after the decimal. Here we have one number, and here we have 3. So we're going to focus with our 3.5 since it has the fewest digits. 3.5 plus 1.209, that is going to give us 4.709 milliliters. We can only have one number after the decimal, so we're going to round this to 4.7. I don't know why that line keeps showing up. 4.7 milliliters. Go ahead and try this example on your own. And again, as we go through these practice problems, be sure that you can pause the video, see if your answer matches the correct one. We're going to move on to multiplying and dividing. So the rule's a little different with multiplication and division. We need to round our final answer according to the number that has the fewest significant figures. And what that looks like, very similar to the process that we use with addition and subtraction, except now we're focusing on sig figs instead of decimal points. So we count how many significant figures each number has. We focus on the one that has the least amount of sig figs overall. We complete the problem with multiplication or division, and then we round the final answer to the number of sig figs that from step one for whichever number had the fewest. Again, sounds a little more confusing than it actually is, but with a few examples, it should make sense. So if we think about 7.21 times 2, 7.21 has 3 significant figures. Let me find my pen. 2 has 1 significant figure, so we're going to focus on the 2. We have 7.21 times 2. I'm pulling up my calculator. It gives us 14.42. Again, I apologize for the random line. 14.42, but we only have 1 significant figure with our number 2, so we need to round 14.42 to 1 sig fig. So we're going to round after our first digit. There is a 4 after the 1, so it will stay a 4, or it will stay a 1, and then we will add the 0. So again, this is a big round, but 10 is going to be our final answer because we can only have 1 significant figure. Let's try another one. 1200 divided by 3.50. 1200 has 2 sig figs, the 1 and the 2, and 3.50 has 3 sig figs. Again, if you're confused as to where these numbers of sig figs are coming, make sure you relook at the video from the previous class so that you can understand the rules for counting sig figs. We're going to focus on the 1200 since it has the fewest number of sig figs, and 1200 divided by 3.5 will give us 342.857143, but when we round, we only want 2 sig figs in our answer. So we are going to round between the 4 and the 2, bring the 3 down. Since it's a 2 after, the 4 stays the same, and we'll put a 0 to hold the spot. So 340 would be the answer according to the sig fig rules. One more example, 456.1 times 6.4. This has 1, 2, 3, 4 significant figures. This has 1, 2. So we know our final answer will have 2 sig figs. 456.1 divided by 6.4 gives us 71.2652625. We only want 2 sig figs, so we've got to round right after our 1. Since it's less than 5, it just stays at 71, and that's going to be our final answer. Again, try this example on your own to see if you get the correct answer. And again, as the practice problems show up, make sure you're pausing the video, trying the question on your own, and then comparing it with the correct answer to see if your response matches.